So welcome to our breakout session, Multibody and Weldments versus Traditional Assembly Design. My name is Adam Benson. I'm one of the application engineers at Quest Integration. And this breakout session was one of the many that were available during our Tech Day 2015 event earlier this year. So I hope you guys enjoyed the content that I put together for you today. Let's go ahead and get started. Here's some of the items that we will be covering in this session. Weldment profiles, the creation of these weldment profiles, some of the added options that we can include with that as far as custom properties go. Weldment feature, what the benefits of the weldment feature are. Any sketch considerations that we have for our layout sketch with our weldment part. An overview of the structural member property manager. We'll show some examples inside of SOLIDWORKS of that. The advantages and limitations that we have of multi-body parts and when to use an assembly. And then also getting into Cutlist, some of the options that are available with our Cutlist, and using that Cutlist in our bill of material for an assembly that includes weldment parts. And then finally detailing that weldment part on our drawings. How can we bring over those individual bodies? So taking a look first, our weldment profiles. How can we create these custom weldment profiles? And that's just it, they're custom weldment profiles. This can be any cross section that we want. We simply start by creating a new part. And all the weldment profile consists of is a sketch. So we create that sketch, we define that sketch how we want it, and then we save the part out as a library feature part. And this is what the structural member command is looking to, is that library feature part. Now we want to make sure that we save this in the same location that SOLIDWORKS is looking to for our weldment profiles. We also want to keep in mind of the folder structure. So the way that SOLIDWORKS is reading this is I have a folder for the standard, and then I have a folder for the type, and underneath there I have the library feature part, and that is my size. Now we can also take advantage of configured weldment profiles where I may have a similar cross section but different sizes, so we can create those different sizes as configurations. If that's the case, our folder structure changes just a little bit. So then we have a folder for the standard, and then our library feature part exists in that folder as the type. Our configurations then become the sizes. Now what's nice about this is we can include custom properties with these weldment profiles. So every time that I use a particular weldment profile, if I wanted to have, let's say, a particular description property, we can add that as a custom property of the library feature part, and the next time I go ahead and use it, it'll add that to the cut list properties. Now when we're working with a part, at any time I can make that part a weldment, and we simply do that by clicking on the weldment feature. And when I do this, it's doing a few things for me. It's enabling weldment specific commands, things like the structural member command, the trim extend command. But it's also replacing the solid bodies folder with a cut list folder. And so we can take advantage of the different cut list items and grouping those together and using the weldment cut list on a drawing. We're also getting configurations generated for us automatically. We'll have an as machined and an as welded version of our part. You will also notice that the merge result checkbox defaults to unchecked from then on out. So anytime that I add an additional extrusion where I'm adding material, normally I would see that merge result checkbox checked. It is going to be unchecked. And that is because we are creating a multi-body part. So we're adding additional solids. The weldment feature will actually show up in the top of the design tree when I click on it, and it acts as a custom properties holder for our cut list items. And so what this actually does is it'll apply a custom property that we choose to all of the cut list items. And we can access that by right-clicking on the weldment feature in the design tree. Now with these weldment parts, we're dealing with layout sketches, and there's some considerations for creating these layout sketches. We definitely want to take advantage of patterns and symmetry. This is really in all areas of SOLIDWORKS, but really focusing on it with the weldments. It saves us a lot of time in creating these layout sketches. We also want to keep our structural member groups in mind. It's important to know what can be selected and added or grouped within the same group. 2D and 3D sketches can be used individually or in combination. So the benefit of this is I can have multiple sketches used for my layout of my weldment parts, and I can utilize different sketch entities from different sketches within the same structural member feature. And to continue that, we can reuse those layout sketches. So the structural member feature itself in the design tree is not absorbing that sketch when we use it, like we typically see when working with sketches in parts in SOLIDWORKS. The Weldment Profile sketch, again, is just a cross section, but where does it start when I do the sweep along the line segment? Well, it starts at the point where I created the sketch segment in my layout sketch. And so that might be important to know if you are going in and making any changes to the position of that profile. And then also, you can see up on screen here, I have an example of this. More than 2 path segments sharing a common vertex cannot be selected within the same group. So here I've got 3 lines meeting at that point. I'm going to need 2 separate groups to create that structural member. Now getting into our property manager for our structural member feature. And we'll take a look at this getting into SOLIDWORKS so you can see the mouse clicks, get familiar with some of these different options and where they're located, as well as how to use them. But let me just run through it really quick here on the PowerPoint slide, and then we'll jump into SOLIDWORKS. So first at the top, we're picking the type of weldment profile that we're going to use for this structural member. Now if I have multiple items to select in my layout sketch and different cross sections, those different cross sections are going to require different structural member features. But if I'm using the same cross section, I can select multiple items and place them into different groups. So for these groups, if they are connected at ends or parallel as far as the layout sketch goes and the selections that I'm making, they can be placed in the same group. Any items that are not connected at the ends or parallel would need to be created in separate groups. We also have the ability to apply a corner treatment. So an overall corner treatment from the selections that we've made for each group, and that is group specific. We'll get into trim order here, and I'll show you an example of that, of where we can do that individually. We can also change the profile position if we choose to. So I can mirror that profile, I can align it if I have some reference entities. I can also change the rotation of that by entering in a degree value, as well as hitting the locate profile button that you'll see at the bottom of the property manager. And this allows me to select different points of that weldment profile. Now by default, when I create that weldment profile and I have that sketch, the pierce point, the default pierce point, is the origin of that sketch. So typically you'll see that at the center, but that may not always be the case. Just keep that in mind when you initially create that custom weldment profile. The pierce point, when you go to use it with the structural member feature, is going to be at the origin of that sketch. Now there are times, like I said, where we have different structural members, different cross sections. And so one of the benefits of utilizing weldments and structural members, and for these structural members with the same profiles, is they're trimmed automatically for you. But if I'm using multiple structural members here with different cross sections, I need to go in there and manually trim those. And we use what's called trim extend. And there's some different options that we have available. We can choose to keep or discard certain bodies from that trim. We also have some options for extension, as well as choosing different items to trim with, whether it's a face or a body. And so we'll take a look at an example of that here right now. So let's jump over into SOLIDWORks. And I've got an example here of just some groups. So with this, I have one structural member, right? We've created 3 different layout sketches here. Excuse me, 4 different layout sketches here. And I'm using all of these in the same structural member feature. So again, I've chosen the Weldment profile that I want to use. And for my first group, because these are all connected at ends, I'm able to select all 4 of those line segments. For group 2, I needed to place this in its own group because it's not parallel with any of the other sketch entities, and it's not connected at any of the ends or the other groups. And same thing with group 3. Now group 4, all of those line segments are parallel, so they can all be a part of the same group. If we take a look at group 1 here, here's where we can see applying that corner treatment. So I have a miter, I have an end but 1, and an end but 2. And we can see the changes that get made there just right from the preview as we click on some of these different buttons here. We can also add weld gaps if we need. Like I said, we can change the location of those. If I choose locate profile, you'll see that it zooms into the Weldment profile itself. And any point that I have on this, I can choose as the new pierce point to change the location with respect to my layout sketch. Let's take a look at another example. Our trim order. So I mentioned over here that we have corner treatments, and we can apply these corner treatments per each group. But what if we want to come in and make a change in a particular location? Maybe just one corner we want to change to be different. We can do this using the trim order. And so I can come on screen and I can click on one of these ends, and this will bring up my trim order and the components between that. And so we can make changes to that if we'd like individually. For instance, if I came in and I selected this corner here where I've got 2 bodies that are crossing, one body's cutting the other 2 bodies, and so now I've got 2 bodies here. What if I wanted that to work in the opposite direction there? So one full body in the length this way and split this body here into 2. Well, we do that by changing our trim order. So the lower on the trim order is going to be the one that gets trimmed first. So if I don't want this one to be trimmed, I can change the trim order and I can match or reverse the selection there for, or the trim order there for those different groups. So now this one has a trim order of 1 and group 1 has a trim order of 2. So I've changed how that's being trimmed. If we hit OK, we can see the difference that we see with the opposite side there. So that's how the trim order works, and again, that can be applied to these corners individually, whereas in the property manager for the structural member, it is for the group overall. So here's an example of where I have different cross sections within the same Weldment feature or Weldment part. Right, so again, if I have these different cross sections, I create different structural members. And we can see that these aren't being trimmed, right? So I have some intersection, some overlapping. If we take a look at our Weldment tools, we have the option to trim or extend. So we'll go ahead and take a look at the trim extend. Now I also have different corner types for this as well that I can choose. So for end trim, I can pick my bodies to be trimmed and then my trimming boundary. So whether it's a face or a plane or any bodies that are creating that trim. So I can come in and I can simply select this body. Now notice how when I did that, it didn't just cut the end off here, but it actually extended that structural member out to meet up with this body. And that's an option that we have available over in the property manager here to allow for extension. If I uncheck that, you can see then with the descriptor, with the preview, it's just cutting off the bottom. So that's the difference with that option there. We could also use the trim extend on the other side as well. So my bodies to be trimmed is going to be this body. My trimming boundary is going to be this body. And you'll notice that when I do that, it actually splits this body up into two separate bodies, which is what we would expect. But what's nice about this is it allows me to click on these callouts to choose bodies that I want to keep or discard. And SOLIDWORKS is pretty intelligent in knowing which bodies you want to keep and which bodies you want to get rid of. We can also take a look at the same option here to allow extension. If I have that checked, you'll notice that it's cutting all the way through. If I uncheck it, it's just going to remove the portion from that trimming boundary body. We can also change the profile for how these are cut. So I have cut between bodies, or I can have a coped cut. So I can change that option there as well. If we're cut between bodies, of course we can add that weld gap as needed. So those are some of the options that we have available with our structural members and also with the trim extend feature. What are some of the advantages though that we have of these multi-body parts? Well, in order to understand this, we need to consider how it would be built as an assembly. If we take any one of those that I just looked at as an example, building those as in an assembly, we would need multiple files. We'd be creating in-context features if we wanted the model to be parametric at all. We would have the additional mates there as overhead. And then what if we need to make a change? It's not as easy to make a change. By utilizing these multi-body parts, specifically with Weldments, they're very easy to modify. We simply have a layout sketch. We make changes to the layout sketch, and that drives the structural members and all of the additional bodies. And it's all updating our cut list, right? Grouping all of the like bodies into the same cut list items. But of course, with some advantages comes limitations. So we do have some limitations of multi-body parts. They can't easily be repositioned, right? If we have any movement, dynamic movement, it's not possible with our multi-body parts. This needs to be done as an assembly. If we want to reposition these components in an assembly, we can grab those and simply just move them around or add mates to position those. With multi-body parts, we need to utilize the move copy command or modify sketches or features or change planes that we are sketching on. When working with large weldment or multi-body part models, we may experience slower performance than assemblies. And this is simply because we have a lot of options available to us to aid in performance for those large assembly file sets. When it comes to multi-body parts, about the only thing that we have there is the freeze bar to help us control the rebuild time of those features. And then also when it comes to detailing the drawings of our weldment bodies, they are going to be tied to the weldment part. Now we'll get to ways that we can insert these bodies individually into the drawing, but just remember that they're always going to be referencing that weldment part file. And we have to consider the company standards when it comes to this. So when should we use an assembly? Well, we have to ask ourselves, should the part be listed separately in the bill of materials? If it should be listed separately in the bill of materials, we may consider using an assembly instead. If it requires its own detailed drawing, like I said before, with the weldment part, it's going to be tied to the weldment part itself, not the individual body. And should we have some freedom of movement within this set of bodies? If that's the case, we need to use an assembly. And then again, just to reiterate, we need to consider any company standards. So if I have an existing assembly and I want to make that a weldment, make it more efficient, we could take advantage of weldments with this assembly. Where do I begin? Do I have to start from scratch? And the answer to that question is no. We can convert our assemblies to weldments. It does take a little bit of work to do so, but we're not completely starting from scratch. And so here's the steps that we can take to do this. We can save the assembly out as a part, and then open up that part as our new weldment part, and we can start to define a layout sketch if it's needed, and then we can create these new weldment bodies in place of the old parts using just features that we have available at the part level inside of SOLIDWORKS. And as we start to replace these old parts with these new weldment bodies, we can hide the old bodies through the design tree. And then once we've replaced all of them, as a final step, we can use delete bodies to clean up and get rid of those old bodies. When it comes to our cut list and our bill of material, we can generate 3D bounding boxes for our cut list items. This helps with giving us a length, width, and height that we can use for description of some of these weldment bodies. Maybe we have feet for a table that are simple plates, and we've added those to our cut list. With a 3D bounding box, we can easily get the length, the width, and the thickness of that plate, and we can have that added to our description. We can also rename our cut list items with that description value if we want, and this is now an option available to us through our document properties. You'll notice under document properties there's a weldment section there where you will find that option. One thing that I really like about the cut lists is they are just like the bill of material. It's like a bill of material for a weldment or multi-body part. We can customize these tables, add different columns, change the formatting for it, and then we can save those out as table templates to reuse again. We can even take these cut lists and insert them into a bill of materials. So if I have an assembly that contains multiple weldment parts and I want to see those show up on the bill of materials at the top level assembly, we can choose to insert an indented bill of materials, or we even have the option to dissolve the weldment part if we desire. So now we need to detail these multi-body weldment parts. How do we do that? Well, let's go ahead and take a look at an example inside of SOLIDWORKS. There's 3 ways that we can do this. Really, I prefer only using 2 of them. But if we make a drawing from this part, I can insert a particular drawing view, and you'll notice that because I have multiple bodies with this part, if I click on that drawing view, I have an option to select bodies. This allows me to then come back to the part file itself and choose the scope for this drawing view. So I get to select which bodies are going to be included with this. And it's going to show me that body in the orientation of, in this case, a front view. So that's one way that I can create a drawing view of the individual bodies. The way that I prefer, and the reason why, is because I can change the orientation to however I need to show it on the drawing, and that is using relative view. So if I come in, right click, come down to where my drawing views are located, you will see relative view. By doing this, we can jump back to the part, and again, we can determine the scope and the orientation for this drawing view. So if I want the entire part, I can then just change the orientation. We can also choose select bodies. So I can come up and I can pick this body, and then it allows me to change the orientation of this. So maybe for my front, I want this face, and for my top view, I want to be this face. Once I've done that, I can simply hit OK, and I can bring that drawing view into my drawing, and it has changed the orientation for me based off of the faces that I've selected. An alternative way to do this, and not the method that I prefer, simply because the bounding box or the boundary of the drawing view can get quite large with some of our bigger weldment models, but we can generate a display state for this. So if I wanted to, I could come in and right click and choose to isolate a particular body, and then I can come in and I can save as a display state. Now when I jump back over to my drawing sheet and we go to insert a particular view of that part, we can utilize that display state. So you can see there it's just showing that body because that is the only body that I was choosing to show for that particular display state. Again, the drawing view border can get quite large there. Depending on how big the model is or how small the body is that you're trying to show there. So just keep that in mind when you are using that method if you decide to go that route. Well, I hope you guys enjoyed the presentation. As always, if you have any questions, feel free to contact us. Thanks for watching.